Welcome back to another episode of the Earth Science Classroom. We're looking at geoengineering. So this kind of series is more like current, more experimental, more on like reviewing articles and seeing what's out there across the world scientifically with geoengineering, which is a kind of a new kind of term. And today's episode is on cloud seeding. So we're looking at the history of cloud seeding and the story behind the first time a scientist actually cloud seeded an area, a part of the world. All right. So today we're looking at cloud seeding, and the first one happened in 1946. And it was kind of an awesome kind of story. And it was between, well, first it was centered around a company, very well famous, GE, or General Electric. And they had their hands in lots of different sectors of industry. And of course, in 1946, they were a big company involved with the military, with the army, and trying to use their scientists, use their brain power, their know-how, their experience with scientific inventions and discoveries and applications with different military weapons, that kind of stuff. Their focus was on helping the military and completing contracts that were given by the military. And there were four scientists, all right? There were two or three main scientists, and there was one lab associate that helped out as well. And don't get me wrong, the lab associate was also a genius. They're all geniuses, and this is kind of the story. So the four gentlemen was Langmuir Schaefer, who was the associate under Langmuir. Langmuir was like the more experienced, very well known, very highly regarded scientist in this field. There was also a lab associate called Maynard, and another main doctor was Vonnet. So these four gentlemen all worked in GE in their science lab, and they were working on military contracts. And mostly at this time, it was for airplanes. And it was the investigation into the static electricity that is created by precipitation in the clouds. That because of the bipolar or polarization of clouds, especially thunderstorm clouds with a very vertical growth and very high elevation, then you get the static electricity that builds up. When the plane flies through, you don't want it to fry the instruments or navigation or the weaponry. So they were looking into how to reduce or counteract this electrical issue with planes. So this is basically during the war, so obviously 1939 to 1945. Now, their work with clouds, their work with the atmosphere, their work with precipitation obviously gave them a lot of data. And once in 1946 the war was kind of coming to an end, they turned all their attention to different applications. So Langmuir actually kept working with the atmosphere. And he was interested in trying to produce rain or produce precip inside a cloud, how to induce it, how to artificially induce a cloud to produce precipitation or produce more snow or rain. Now, his first attempt was up in the Adirondacks in New York State, and pretty much started to gain experience, gain knowledge, and also this was studied in Mount Washington in New Hampshire. Now, Mount Washington is famous, actually on the east coast of America, to have very severe wind and very severe winter weather based on the elevation and topography and terrain of that area of New England. So they were practicing this up in New England. And why New England? Well, the GE laboratory was based outside of Albany, which is the state capital of New York. Now, if you're from this area of the Northeast, this is called upstate. Anything north of the New York City is kind of upstate. Kind of crazy because New York City is a very small part in terms of land area, and New York is a very large state, but that's what they call it, upstate New York. So outside Albany. So the Adirondacks were close, and also New Hampshire was close to get to and experiment in. So after months of these experiments, the breakthrough came. Now, Langmuir went back to his what's called cold box, which is a laboratory room that was kept at a certain temperature. Now, for some reason, the morning he came back to see the cold box and to continue his experiments, the door had been left open and the cold box had obviously heated up, room temperature, and that was not good for his experiment. So in order to quickly get the cold box back to the right temperature that he desired, he went down to a nearby lab in the GE complex and took some dry ice. Now, dry ice is solid CO2, and it is a very cold temperature. So it's negative 78 degrees centigrade, or that's negative 109 degrees Fahrenheit. So it's extremely cold. You were to touch it with your bare hands, your skin would instantly feel the cold, and frostbite would set in very quickly. Obviously, over more tender areas of your body, it can be very, very painful, even cause the skin to die as well if exposed for a long time. So obviously handle with care. And he basically took some dry ice and he put it back in the cold box, and what he saw was obviously the condensation. Condensation happened quickly, where there was basically lots and lots of basically cloud of gas being released. Okay, so the dry ice does not go into liquid. And that's why it's called dry ice. There's no liquid component. There is no liquid phase in change. So this solid CO2, if heated, goes straight into a gas. And this is called sublimation, or it sublimates. It basically bypasses the liquid phase or stage of matter, or state of matter. This happens occasionally on mountaintops when the sun hits the ice or snow very quickly, with a very sharp increase in temperature, but dry ice has it, and this is why it's called dry ice. It doesn't leave any liquid residue. So what he saw was he was manipulating the air with this dry ice, and he was creating thousands of ice crystals inside the cold box, which he had not seen before. And this kind of opened the gates to understand the cloud condensation nuclei and the coalescence theory and all of this stuff, where he could use dry ice as a stimulant to create these ice crystals in the air to really basically make snow. And so the next thing was he then went off to the Adirondacks again, and in November 13th, 1946, he successfully seeded the first cloud in the Adirondacks. And that was the breakthrough. That was the initial first ever cloud seeding in the Adirondacks. So once GE realized what they had done, they started to market it. They started to advertise it, obviously as a way to advertise GE and their expertise and their ability to have their scientists produce, clouds and snow from nothing, but pretty much. And they started to promote it, but on the other hand, they started to worry about the liability the company could face if something goes wrong. You're trying to manipulate the weather, which could lead to various lawsuits in the future. So they tried to back off, and also GE couldn't afford to give the scientists what they wanted to continue with their research. So what happened was the naval research got involved. Obviously, it's in their best interest to know as much as they can with the planes, was to basically dump in a load of money and fund all of their research. So they were able to start this thing called Project Cirrus. And this project was influential in really pushing the ideas and boundaries of cloud seeding and what we could use to seed the clouds and to effectively create rain, snow, or more rain in certain areas of the world. It's great for crops, agriculture. Could even be used as a military application, flooding perhaps, or drought perhaps, or to not have cloud seeding. So what happened was they went to New Mexico, and here they had a very nice atmospheric condition where the clouds would move pretty slowly and not very far. No real high winds to move these large thunderstorms around, and they worked on thunderstorms that were created because of orographic lift. So it was lifting over the mountains, having these large thunderstorms develop from the mid-morning through to late afternoon, and you could literally, expect them to work on this time scale, and then you could seed the clouds and then watch in that local area the effect or lack thereof of these clouds that were seeded. However, there's always something going on. There's always someone complaining. There was a brewing company called Coors. You may have heard of them. Coors, back in 1978. All right. Coors had fields in Colorado, right, growing their barley for their beer, and they were upset because this could affect the rain in Colorado if they were manufacturing more rain in New Mexico. They were worried that it could take away the rain and reduce the barley yield, and therefore reduce beer they can sell. So there was a lawsuit, of course, and it was getting a little bit tenuous for GE as well, with their scientists involved, and that was kind of the start of it. And the next thing was very controversial, was Langmuir started to discuss the possibility of diffusing natural disasters like hurricanes, trying to manipulate and adapt hurricane development so it would diffuse a hurricane before it became a large storm. So because hurricanes are a collection of thunderstorms over tropical hot water, so the application was just to adapt it to a larger system, like a hurricane. But that was very controversial, and pretty much was stopped in its path. Bonnet then used silver iodide. Ooh, okay. That was basically that particulate matter that was sprayed into the atmosphere at ground level that would stimulate condensation coalescence in the atmosphere. Again, one of those materials they found to stimulate the cloud seeding, was to use with cloud seeding. So this is, again, very, very interesting, because this started quite a long time ago, right after the war. And again, for military application for the planes came the cloud seeding idea. And, obviously since lots of lawsuits in the 70s and 80s, it's been diffused. But again, it's come back into the mainstream the last 20 years with commercial airplanes and their contrails, their chemical trails. And there'll be more videos about that, but again, this is the first ever cloud seeding, 1946, New York State, GE, and using dry ice. Thanks, everyone.